When you talk about machine learning, it's the same thing. So if you use neural network, if you want to train machine to think, you give it an input and then you get an output. For example, you want to see image processing. When you look at image, you want to decide what image is this. So you train the neural network beforehand, you train them, this particular image, the output is this. I mean, this particular image is girl, this particular image is a boy. So you train them. So after a while, you train the machines and it can make its own decision. So anytime you look at other pictures, it will be like, okay, I can decide this is a man, this is a boy at 12 years old. But it requires a lot of trainings. That's what they call it, the machine learning trainings, okay, the deep learning and whatnot. The idea is for you to train to give them input and output. So if you talk about neural network, it's all about input and output. There's a computational inside the neural network that decide what's the output, what is the decisions you want to make. The AI or the neural network will bring a new dimension to testing. The fact that it will make things much faster than what it is today. We use neural network in predictive maintenance. So the term predictive maintenance, they always go down to identifying what is the required maintenance of the machines and predicting when is the right time for us to maintain it. Take for example, the one project that I'm working at is they call it the APR, Acoustic Pulse Reflectometry. So in a nutshell, the acoustic pulse is used to detect failure in pipes. So you see one long pipe, okay? You send a signal, you send an acoustic pulse, like a very short time sound. You send it down the pipe, all the way inside the pipe, and then it bounces back at the end. Okay. When it bounces back, it comes back to the sensors. So the sensors will look at the reflections, and the reflections will tell us what is happening inside the pipe. Okay, for example, if there is a reflections, okay, imagine a pipe is 1 kilometer length. There's a blockage at the center. When you send the sound from here, it travels to the end, okay, and come back. But when the sound travels here, it will bounce because there's a blockage as well. So these informations, with some algorithms that using time and whatnot, we use the time domain analysis to identify what kind of blockage is there in the pipe, the size of it, the severity of it. All this we need to train on the signatures of okay, you see this kind of blockage, what's the sound be like, what's the reflection of the sound be like, that kind of blockage, okay. So we train the machine to understand the reflections, the signature. So each and every reflections, we send it to the machines and to pair them, the input and output, as I was telling you once again, to pair them. So then once we train them, we start doing the predictions. How we do it? This time around we move it within the pipeline, and then we look at the reflections and we start looking at it. We get information, the output, where is the predictions, where it is a failure, and then we look at it. Is it true or not? So that is how we train the machines. We started off in findings the way of defining the right path or the right acoustic path to send. So we started about 2 years ago, and now we have come to a point now that we can sort of predict 98% of blockages type in pipes. So when you have predictive maintenance, you will surely be able to automate or to simplify the defect detections and whatnot. We talk about TIC. Okay, it's all about in the quality assurance part. So instead of having to go through a common lengthy process and see a good promising applications of the network and making those process become much faster. A lot of other solutions that it will be dependent on our data training, maybe on blockchain, and the future is to have all this connected within the governing of ESG.